Hey folks, I wanted to give you a run through of calculating an octagonal silo, just because it is on the test in the term 3 test, so make sure we get some practice with this. One thing to note is that if we treat the octagon like a square, it can save us a lot of work. And so a few little tricks that we talked about in class, and you can see in your textbook, is that when we treat it like a square, it's much easier to calculate area this way. It's also a lot more helpful to figure out the length of our sides, right? So as we've always been doing when we're calculating a foundation of some kind, we want to find the center line perimeter. And for the octagonal silo, it's no different. So we'll find our center line perimeter, and that center line will serve us well for both our foundation wall and our footings. Okay, so to start, what we're going to do is we're going to add on half the thickness of our foundation wall on this side and half on this side. So in effect, we're going to add on 300 millimeters to the 4.88 meter dimension, because this dimension is taken to the inside, okay? So what that looks like is this. We took the 4.88, we added half the foundation on the right side, half the foundation on the left side, and that gives us a total inside diameter of 5.18 meters. Okay, so what we're going to do is we're going to go 5.18 meters squared plus 5.18 meters squared, and then we're going to square root that. That's our Pythagorean theorem, a squared plus b squared equals c squared. And when you do that, you're going to get 7.33. So that is the hypotenuse if we were looking at this as a square. Now, interesting thing, because this octagon is symmetrical, meaning all the sides are the same, if we took the 7.33 and we go minus 5.18 meters, they're both meters, if we take the hypotenuse divided by, or not divided, minus the diameter here, that actually gives us the length of one of the sides, which is 2.15 meters. Okay, so if we go back here, you can see that if we have the center line length of one side, and this is symmetrical, well, we just need to multiply that by 8, and that would be the complete center line perimeter. Okay, so if we take, I'll throw in the calculator, 2.15, and we multiply it by 8 sides, we're going to get 17.2 meters. So it's a 17.2 meters all the way around, okay? So let's have a look at our formula. So we're going to look at the volume of the walls. We have 17.2 meters is the center line perimeter, so that's the entire distance around. Now our foundation walls are 300 millimeters thick, and they're 3.2 meters tall, so just over 10 feet tall. Okay, so pretty simple. Center line perimeter times thickness times height, and throw that in your calculator, and you should get 20.70 cubic meters. You can also write cubic meters like this, meters cubed, if you'd like. All right, so our footings, we are going to use that same center line perimeter, so it's still going to be 17.2 meters, but our footing is 750 wide and 250 thick, okay? So 7.2 meters, oh, sorry, that came down. 7.2 meters is the center line perimeter times the width times the thickness, and that gives us 3.23 cubic meters for the footing. Now the foundation, the slab I should say, is a little bit different. So what we need to do is figure out the area. So let's go back, looking at this. What we want to do is figure out all this area in the middle here. Now that 4.88 is the actual inside diameter, okay? And so like we said, we're going to treat this like a square, right? Now the interesting thing is, if you treat an octagon like a square, what we have to do is then just cut the corners off. So if we calculate the area of the total square to begin with, and then we subtract for these 4 blue corners that I'm scribbling in here, then what you would be left with is the area of just the octagon, this green portion here in the middle. Okay, so very simply, if you go 4.88 times 4.88, which would be area equals length times width, just our basic area. I actually didn't calculate this before. 4.88 times 4.88 we're going to get 23.81, and that will be meters squared, because that's area. So 23.81 meters squared. So now, what we got to do is get the length of one of our sides. If you remember from our talks earlier, if we take the length of one side and we kind of origami fold this into a square, we would have 4 equal triangles that would make a square. So all we need is the side length of one, and that'll just be one length and one length. So in order to get the side length of just one side, I'm just going to write down this 23.81 here, 23.81. All right, and so in order to get the length of one side, remember we're going to take the hypotenuse of this, and we're going to subtract 4.8 from the hypotenuse, okay? So in order to do that, we go 4.88 squared plus 4.88 squared, and then we square root that in our Pythagorean theorem, and we get, for our hypotenuse here, 6.90 meters. So now all we have to do is go, now I'll throw it in the calculator so you can see it, 6.90 minus 4.88, and that gives us a side length here. Now remember, we just did this, but that was for the center line perimeter. Now we're doing it for inside the foundation walls, like you're sitting inside the basement here. So the actual length here is 2.02 meters. Okay, so now we know that the area of the entire square is 81 meters squared. So the 2.02 is the length of one of these triangles, right? So that's 2.02, that's 2.02. So basically, in effect, what that gives us, when we combine all that, if we combine all 4 corners, it creates this square. So all we need to do is 2.02 times 2.02. And that's just our area. Again, area equals length times width. So this is our length and our width. And we're going to subtract that off of our total. So 2.02, why don't I keep doing this for you guys? 2.02 times 2.02. Okay, so we had a total area for the square of 23.81 meters squared. We're going to go minus 4.08 meters squared. Okay, plus 23.81. And sorry, I inverted it. And anyway, so this is 23.81 minus 4.08. And we have a final area of the green space of 19.73 meters squared. Now all we have to do to get our total volume is to look here. We have our slab is 150 millimeters thick. So we're going to take this times 0.15, okay? And why don't I just do that? So 19.73 times 0.15. And so the amount of concrete required for the slab will be 2.96 meters cubed. All right? So I hope you guys found this helpful. Please let me know if you're still having trouble with this. And definitely have a look in your chapter looking at this, and just keep practicing. It's very similar to rounded silos. It's just got that extra step of taking off the corners. All right? Take care, guys, and happy practicing.